Now let's examine some of the common solar panel choices to see what the market offers. The most common application isn't crossing oceans, it's trickle charging or maintaining a battery. This only requires a few amp hours per day, so panels like the Sunsei solar battery chargers work perfectly.
So these are Sunsei Solar Saver panels, and they're beautifully made. These are designed to maintain batteries when you're not on board your boat, or for that matter, your RV or your car. You can take this little one, plop it inside your dashboard of your car, run from its 12-volt outlet into your cigarette lighter, and keep your car fully charged because, cars have a lot of electronic loads now that never turn off, and if you leave your car too long, you come back to a dead battery. So this puts out about 150 milliamps, so you get close to an amp hour every day. The medium-sized one puts out 500 milliamps of power. And incidentally, inside this package, they come with all sorts of cords and connectors and things that make it easier to integrate into either your vessel or into your car. So this is a square format panel. And the challenge, of course, is what do I do with this when I want to mount it? Well, if you want to mount it on a boat, Sunsei has this really cool mount that's specifically designed for this model. It's adjustable about 50 different ways. And what you end up doing is snapping it together. This goes together like some giant erector set. Now you have a ball and socket mount, so you can adjust the panel. And as we've said before, it's critical to have the panel pointing straight at the sun. From there, you can go to either this flat mount, where it drops in here and allows you to clamp it and have it pointing towards the sun, or you can go to this rail mount, and this will clamp around either half-inch, 3/4, 7/8, or 1-inch railings. And so this will stick in here, and you can adjust it to just the right angle. When you're done, all of this folds up very compactly, and in fact, the whole mount comes in this bag, and you can stow it any place you want on board.
Now at this point it gets a little complicated since battery sizes vary and the chemistry and age of the battery determines how fast it self-discharges. Plus, you may encounter shadowing from trees, masts, clouds, and so forth, so it's dicey to use some precise formula and think you've come up with an accurate answer.
So here's a shortcut. If you take the output of the solar panel in milliamps and divide it by 2, that's about the size of the battery it can maintain. A 150 milliamp solar panel can maintain a battery up to about 75 amp hours. The 1500 milliamp hour panel can keep a big battery bank fully charged, assuming, of course, there are no loads on the batteries other than self-discharge.
If you're concerned about damaging your new gel or AGM batteries due to overcharging, you can add a small, inexpensive solar regulator to ensure you won't turn your dreamboat into Chernobyl. These regulators are rated to the maximum number of amps in your solar array, and we offer a 10 amp and a 25 amp version. This is ideal if you can't be on board to monitor your electrical system.
The next series of panels produce substantially more power, and they are intended to be mounted permanently, or at least securely. There are 3 models by Sunsei and 2 models by Sun Solar. The Sunsei polycrystalline panels produce 4, 6, or 8 amperes, depending on the physical size. Polycrystalline panels are more efficient for a given size of panel, so you need less area for a given amount of power, or you get more power from the space that you have available. Our company's sailboat, Promotion, consumes about 120 amp hours of energy per day when we are cruising. 2 of these Sunsei 6 amp panels could be coaxed into producing more than half of the energy consumed, which would reduce our engine runtime in half. Now that we know more about how much energy panels are able to produce and how they're packaged, let's look at some real-life examples of power consumption on board a cruising boat. One way to do this is to create an energy budget for your boat by adding up all of the loads you normally operate or by using an amp-hour meter to do the calculations for you. If we return to the example of my sail to Hawaii, it provides a simple case of how you can calculate your total energy consumed. My loads consisted of an autopilot that ran for 16 hours a day at 0.3 amps, a running light that ran for 10 hours a day at 0.8 amps, an interior that ran for about 2 hours a night at 1 amp, and a VHF radio that was on standby about 12 hours a day at half an amp. By adding up all these loads together, you come up with about 21 amp hours per day. I ended up selecting a panel that put out 3 amps. And with careful aiming and very little cloud cover, I was able to meet all of my energy needs for 17 days.
So Chuck's example is a little extreme, since he had no other source of power and he had a pretty Spartan existence on the boat. Remember that you don't have to be entirely energy independent. Even replacing 1/3 of your normal consumption can greatly reduce the duration and/or frequency of engine use.